After understanding this, let's try to understand type of thread. We all know that OS operating that mode includes user mode, and obvious is the kernel mode. Now when it comes to user mode, we have an advantage, like you have a huge space, it is cheap due to the space. Again, it is easy to create, destroy or synchronize. So there are advantages, but there is also a negative part to this. The negative part is rights. Another way of saying privileges. There are greatly limited privileges given to the user mode for the security purpose. A reversal of that would be to understand for kernel mode. Now kernel mode does have certain advantages, that yes, high rights. Why? Because we are talking about the kernel mode, and the kernel handles by the OS, making it all the privileges available with OS given to the kernel, and kernel inheriting all these things. So obvious, high rights, better and direct control. The negative side, but on the other side, is space is less. Compared to the user mode, kernel mode always consists less space, creating one major disadvantage. Now, when we work with this kind of stuff, we also have issue coming in. Then why two modes and what is the issue? Let's try to understand. The biggest issue right now, especially when it comes to user mode, is if one thread is blocked, other threads of same process, I repeat, of same process will be blocked. So now what we would do, although all good things happens in user mode, but even if one thread is blocked, all other threads are blocked for the security purpose. Whereas on the kernel mode, we have one blocked, others can continue. So now in this scenario, what would be seen, how things would be operated. Phenomena is fairly simple. The solution is called lightweighted process solution. The logic simply says that if there exists thread T1, T2, T3, and if T3 is due to some reason blocked, the best option is to move T3 down and keep it blocked, but let T1 and T2 execute without any problem. This process or this solution is called lightweighted process solution. But for doing this multi-threading, we have three different modes. Let's talk about them. We have modes called multi-threading modes: many to many, many to one, one to one. Let's see one at a time manner. The first one is many to many, is the first option. Is the first one. Now what is many to many going to happen? Now in many to many, we would be having certain n number of threads in user mode, and for that we can execute m number of threads in the kernel mode. Whenever any thread is blocked or you require higher privileges, that thread will be shifted down and would execute. We again say one simple thing, it is may or may not be. We may have n is equal to m, that is equal number of user thread would have equal number of kernel thread, but in some cases, or rather in most of the cases observed, generally it is seen n less than m. That means if you have 6 threads, you might be having 4 threads in the kernel mode. So generally at the kernel side, we keep less threads. The basic advantage of many-to-many relationship is concurrent processing, because multiple threads which are blocked can be brought down, and people or other threads which are capable of executing will get executed when they are up. Another thing what we have is many-to-one relationship. This is generally used when you have hardly some space at the kernel, because in this n number of threads at the user mode will be mapped to one single thread in the kernel mode. The basic logic behind this is very simple, that due to lack of availability of space, we only provide one possible thread in kernel mode. So from here, any thread which gets blocked, let's say T1, T2 and T3, and this time supposed getting blocked is T1, that T1 will be brought down so that extra attention can be given, but T2 and T3 will continue without any issue. So this is many to one. Concurrency will not be seen because at a time only one thread can be blocked. If multiple threads are blocked, they will enter in a waiting queue. Another thing in multi-threading is one-to-one relationship. Although people misunderstand this simply means that for n number of threads, we have n number of threads in the kernel mode also. That means n is equal to m. So let's make this, I'm making this as m. So we say n equal to m. That means for every thread, there will be one thread available in the kernel mode. Highest amount of concurrency because every thread will have a mapping. So even if all threads are blocked, still you can shift it to kernel mode and then higher writes can be used to resolve them. So this was entirely multi-threading system to understand. I hope people have understood. Thanks for watching this video.